In order to build an application, you have to understand something. A very basic concept in building anything. This concept is the concept of problem solving. You have a problem and you're building a solution for that problem. In the case of software development, the problem is usually having a server, for example, and having to connect that server, this is my little server, can't really draw, to a bunch of people, a bunch of users who desperately need to talk to that server. So this is your server S, this is your server S, and these are your users U. Now the users very much want a way to store information and retrieve that information later. So they've got a database somewhere, or we've got a database somewhere. Sometimes you can also store data on the server, not only in the database, but I digress. There's that little need for the users to store something and retrieve it later, or even not store something but get access to something that you've stored on the server. Now, so there's a two-way communication. There's the users trying to talk to the server, so that obviously goes that way, and then there's the server talking or communicating back to the users, and that goes that way, and this is it. So we have to solve that little issue because we're the techies and the little nerds who write the code. So that is where an application comes in. So you've got this problem, and in order to solve it, you have to build a solution. Now, what I'm actually trying to explain is an architecture. But in order to know why you need an architecture, you need to understand where you're going to apply that architecture and why it's needed. And this is what I've just explained, what you're going to apply it to. You're going to apply it to a solution, a project, a castle, you could call it. So now, in order to explain why you actually need an architecture in your solution, why not just offer them the solution, write the code however you want, and give it to them? Now, apart from the obvious answer of having a modularized code or readable, legible code that other people can understand and you can understand in future when you come back to it, because we've all been there where we've written code and we come back to it a few months later and we don't understand what in the world we're getting at in any part of our code. Now, apart from that obvious problem, right, architectures give you a solution to that, yeah, but that is more well known because it gives you that structure, and because you know the structure, you know that always when you are looking for user interface things, you can go into presentation, widgets and all that. You already know the structure of a project always. You don't have to search to find, right? So apart from that obvious solution, obvious issue and its solution being an architecture, the deeper need for an architecture stems from let me put it in a scenario. Imagine that you're building with a Lego. You're building a really cool Lego castle, and you've essentially got all of the Lego pieces. Some are big, some are very small, and they all fit together in different ways, really. Now, think of that castle as your Flutter application. Each Lego piece is a different part of your code. It could be things like buttons, like colors, text that you see on your screen. It could be the part of your code that talks to a server, or the part that manages the state of your application. It could be different features. Different features could be different blocks, right? So all of these are blocks of Lego pieces. Now, when you're building your castle, you actually want it to be strong, and you don't want it falling apart if you accidentally bump into it. So you use a special kind of framework to build it, and in this case, the framework or the architecture that we're looking at would be the clean architecture. Now, just like how you start with a strong base for your Lego castle, clean architecture also helps you organize your code in a way that makes it very strong and sturdy. So it's essentially like you're looking for a formula to arrange your Lego castles in a way that gives them a very sturdy foundation, so that when you bump into it and it falls over, your little castle falls over, the Lego pieces do not just break apart and just shatter, because they've got a very solid foundation. Right, so we're about to embark on some very explicit examples. So this particular example is the only one I could think of really, is with balls, because I can't draw much else. Oh wait a minute, I could actually draw a square with this. So we've got boxes. Imagine, yeah, that is too much. Imagine that we've got a little of these little boxes over here. Forgive my horrible artistry, but we've got a little box at the bottom. Now, I'm not going to keep drawing boxes over the top of this, but I'm just going to draw rectangles, but it should pass the message along. But what I'm essentially trying to say is, if we had only one box as a base, and we went on adding two, increasing the power of 2, so 2 to the power 0 was 1, and over here we also have 2 to the power of 1, which would be 2 boxes, and we have after that 4 boxes, because 2 to the power 2 and so forth, and we increase a 60. You know how it works, it just keeps going higher and higher. But if that happens, we've got imbalance in this little use case that we've got. So there's an imbalance because the bottom is very much slimmer than the top. It goes like a V. Yeah, but what you actually want for balance is to have an A-shaped structure. This is a lot stronger than this. This would topple over easily. This has a solid base. It's got a very vast foundation. So when you push this, this is very, very large. So it supports this properly. There's balance. All right, it's just all about balance. So this is essentially what we're trying to recreate with a clean architecture. So just like how you start your Lego castle with a very strong base, you also do the same in clean architecture, where it helps you organize your code in a way that makes it very strong and sturdy. Now, with clean architecture, we have different layers, and let me clear the board. Right, so we have different layers in clean architecture, just like different floors of your little Lego castle. So if we had floor 1, and we had floor 2, and we have floor 3, and 4, and so forth, it keeps going up. But you know, so it goes up, it should go up in an A shape, so this is definitely longer than the rest of them, but that is besides the point. With this sort of structure, every layer has a specific job. So one layer could be for how the app looks, which could be presentation of the application, the user interface. Another layer could be for how the application or the solution or the project actually communicates with this server, right? So it talks to the server and it receives information from the server. So one layer could be concerned with doing this. So we don't make the entire code know about this. We abstract it, so only a specific layer knows all about how that happens and how it works. The other layers only know about its result. What did it get from the server? So in that case, we have a different layer for presentation, we have a different layer for getting information from the internet, and we have a different layer for saving data, or for organizing or structuring data, or for explaining how data would look. So it could be anything at all. So this is why we have a lot of architectures, because you could do this in a variety of ways. Alright, there's no wrong way, there's no wrong architecture. The MVVM architecture is a very solid architecture. The MVC architecture is very solid as well. So in order to pick an architecture, you just have to know your specific use case. Now, with the A shape in mind, you can actually think of all of this as let me redraw that A shape. So we had level 1, 2, 3, 4. You can think of it as balance, such that if any layer, so this was layer 1, 2, 3, and 4. So if any layer gets pulled off, because remember the domain will always be, it always will be, because it's pure Dart, so it never gets swapped out. So these layers are quite replaceable, anything can go. This isn't. So the very first layer, which is the domain layer, sits always, but this structure is very solid, such that if any box actually gets pulled out, let's say we pull out 2, the rest of them can actually balance on 1 without falling over, right? Without breaking the laws of physics, essentially. But if we pulled out 4 from the very top, still very solid. If we pulled out 3, 4 can literally rest on 2. So this is why it's got very good structure and integrity. This is also the same in our layering. If we've got a domain layer and we pulled out, say, a state management, right? It doesn't affect any other part of our code. It doesn't affect how, for example, if we had an MVC architecture in the controller or in the repository, you might have to call build context in there and call snack bar or something. But if we change how let's say the framework or something, if we change from Flutter, we no longer have build context, we no longer have snack bars. Now you have to edit the controller, right? You have to edit the repository or whatever else you're talking to. But in clean architecture, you've only got one thing, because everything's got single responsibility. So when you pull out this, it doesn't fall over. It doesn't cause this to be imbalanced, because if we had this sort of structure and somehow we managed to balance it, yeah, if we pull, let's say, this out, it could cause all this to fall over, right? Because it's balanced on something very tiny. So any little shake or any little disruption could literally cause the entire structure to fall over. But in clean architecture, again, I reiterate, anything you pull out will literally not affect the architecture itself. The architecture integrity still stands. We pull out presentation, it stands. We pull out the data source, the backend architecture is still solid, right? So this is what I mean by the A shape and the V shape and their integrities. So for smaller applications, I would say, or smaller, very small applications, I would recommend the MVC architecture. Now for industry applications, what companies usually use would be the clean architecture, as we all know. And actually, the clean architecture doesn't only work in Flutter, it works in other frameworks as well. It doesn't only work in software development, it also works in other fields as well. So each part of your code in clean architecture has a specific job to do. When you do build your application in Flutter with clean architecture, it's like building your application with very strong Lego pieces that fit together perfectly. Now it helps your application stay organized, which we just spoke about earlier, and we decided to forget that fact because it's not very useful, because we all understand it. It makes it also easy to understand, which we've also spoken on. It's also less likely to break when you make changes or add new features, and that is the most important part of clean architecture to me, because I've been in that case where I had a code base and I had to swap out an entire functionality. I only had to touch specific layers and the other layers simply worked perfectly, right? So swapping out a backend, so say we're swapping out Firebase for Node.js, or Node.js with Express with MongoDB. That is an entire stack. Firebase already performs backend as a service, but so you don't need all of that. But when you want to swap those out, you can easily just go to your data source and swap it out. And that is it. Just change how the functionality works. Your tests should still pass. Everything else should still work the same way. You don't have to touch anything else. So when someone, or when you're working in a team and you want, or let's say you're a senior developer, you could quite literally write all the contracts in the domain layer and let the juniors write the implementation. So your junior developers will do all of the implementations based on the contracts that you've defined. So clean architecture's use cases are quite limitless. Alright, so now that we understand why we need clean architecture, let's see how clean architecture helps the user do this better, or how it helps us as developers do this a lot better. we have three major layers in clean architecture, and those are the domain, the data, and the presentation. Right? They go in a specific order. So the very foundation, right? I told you it goes in an A structure. So we have a base, a very strong foundation. That foundation will always be your domain. So the domain layer will always act as the foundation. Why? Because this contains raw code. It literally contains code that isn't tied to the framework. It contains pure Dart code. Right, so whenever you even decide to stop using Flutter in your application, swap it out with a different framework. It could be any Dart framework. The domain layer does not break. It doesn't underline everything with red if you delete Flutter from your system. So if Flutter gets flushed from your system, domain layer keeps standing. That is a very sturdy base. It's super sturdy. It doesn't concern itself with build contexts. It doesn't concern itself with snack bars. It doesn't concern itself with anything related to Flutter. It's purely Dart. So now in the same domain layer, we've got, let me tag that as D. In the same domain layer, we've got contracts that define how the application should work. So we have a contract that tells us how each model for that feature. So we group these. We can really talk about this later, but basically I don't really want to talk about features and how to organize them. But in this scenario, in this case, you can do whatever you want. We've got different ways of grouping features. Now, automatically, you break your solution into features, right? We have the authentication feature. You could have a home page, a home feature. You could have orders, right? You've basically done it in the back end part of the tutorial. So we've got those features that have been organized semantically. So you could either decide to arrange your folders in such a way that you've got features, right? So each feature gets its own folder, and inside each feature you have all layers of your clean architecture. Now this is the approach that I personally always use, but there's a different way to do that, and that's called the feature first approach, and there's a different word called the repository approach, I believe. So in that case you have just one single standard block of layers. So we have the three main layers sat only in your source folder, only three of them. Now in each one, so this would be data, this would be presentation, PR, and this would be DO, domain. So inside each of these you then put in your features. So features come second, but repositories come first. Right, so in here you would then have the authentication. So authentication's data files or modules will live in here in the data / authentication / its things, right? And then in here you would have the presentation, so that would be presentation / authentication / and then you have things like login view, the sign out view, and then in the domain layer you would also have domain / authentication / and then you have all of your domain folders like entities, use cases, and the rest of them. Right, so that is causing me to digress, and I don't want to, so I'm going to erase all of that. But however you choose to arrange it doesn't matter to me, but it can matter to you. But however you wish, you always have these three for a feature. So a feature has its domain layer, which explains the contracts, how the models will look when it's fetched from the server. So when we fetch a model from the server, say a user model, what would it look like? What characteristics would it have? What functionalities would a model have? What can a user do? And so forth. Now we then have the repositories, the repository contract. So these are model contracts, which we call entities in the domain layer. So they're just simply the contracts of a model without the full implementation of them. So just characteristics. And then we have the repositories. So the repositories are basically the functionalities that this entire layer or this entire feature should be able to do. So if we're in an auth feature can obviously do login, sign up, the rest of them. You know what it can do by the backend's documentation. So in the backend that we've built, the authentication can log in, reset password, forgot password, do the forgot password thing, sign up, that is registration if you'd like to call it that. So we would have these things as functions without bodies. We're going to see how that works in code, but it doesn't have a body, but it lives here. It's a contract, called a contract or an interface. Now we also have a third contract, which would be use cases, and these use cases are essentially class representations of each function in the repository. So if we had a registration function or register function in a repository, we come over here and we create a register class, right? And that register class will be connected to this person, so they talk to each other. Now this is a domain layer. Now the domain layer has defined the contract. It's a very solid foundation. Up next we've got two other layers, and those would be the data layer and the presentation layer, right? So this is obviously the UI present. So the data layer directly speaks to the server, and the server directly speaks back to the data layer. So it gets a response, and what does it do? It wants to give it directly to this person, but it won't, because we're not going to let it, because that is super dangerous, because it's got raw data that hasn't been formatted properly yet. Now you've probably formatted your data before passing it here, but it's not completely safe because it's got exceptions that it's throwing from the server, and those exceptions are super raw. You don't want your users being thrown from your application because of your errors or their errors. You want to handle them gracefully, and not throwing them directly from the data layer gives you the opportunity to do that. Now after we fetch this from the server, this presentation layer receives them from the data, not from the data layer directly, right? I'm going to show you there's a little gap over here, this little circle, this little ball that connects all of them. Now the presentation layer speaks to the user, and the user also speaks to the presentation by filling forms, hitting buttons, triggering events. However they do whatever they do, presentation gives and receives, and also finds a way to put it back into this little pool. So we've got a little pool that's sat right in the center. Now the question would be, how do they connect to each other in that little pool? So this person obviously has a connection to the pool. This person has a connection to the pool. This person has a connection to the pool. So how exactly are they transferring information? What manner are they doing that? What direction are they doing it? Now this little thing in the center, this little thing is what we call an interface adapter, right? So it's an interface adapter, IA, an interface adapter. You can look at Uncle Bob's diagram for clean architecture. Let's take a quick peek at that. Uncle Bob's little clean architecture diagram shows us different parts of the clean architecture. Now you can see the interface adapters, and this is what I've just shown you. You've got your frameworks and drivers. These are the technical names for these things. So the frameworks and drivers would be Flutter or React, whatever framework you're using to present your user interface lives on this layer, right? So the presentation layer, like I told you, this is why the clean architecture is so sweet, because it literally is inclusive. It lets you use whatever you want at all. It's not patterned only for Flutter or for a particular framework. It lets you use anything at all. So you can see it's just for frameworks and drivers. So it could be Flutter, web framework, any framework at all. You've got your interface adapter, which could be anything at all. In our case, we're using state management in Flutter to handle interface adapters. Now we've got the application and business rules, which is the use cases. Now finally we've got the enterprise and business rules, which are the entities essentially. Now the version of the clean architecture that we're going to use is not going to be a carbon copy of what Uncle Bob's taught. Uncle Bob's taught clean architecture. He's given us a pattern to follow, and what you do is to adapt it to your framework. So in our framework, we've adapted the clean architecture, and this is what we've come up with. So the IA, meaning the interface adapter, would be this little pool that connects all of them, where they all come for their life source or for their feeding. So they put data in and they also receive data. Now back to this. So the presentation, rather, the user will send data in here. Now that data needs to get to the server somehow. Now in order for that data to get to the server, the presentation has to pass it all the way down here. Now it comes into the adapter. The adapter depends on use cases, not repositories or entities. Depends on use cases that come from the domain, right? So it depends on these use cases. So it goes down and it calls them, and it says use case, give me the registration use case. Now the registration use case is dependent on the repository, right? So like I've shown you, it sends information to the repository and it receives, but this repository is only a contract in the domain. So this repository, when we're doing, or when we're actually initializing our application, we're going to give it we're going to give the use case, which we're going to pass to the interface adapter, a real implementation of that interface, this interface. So, but however, this interface is going to connect the use case to the internet. Now, how does it do that? This little interface is going to somehow find the way to directly connect to the data layer. Now, the data layer has its own repository. It has models, and finally it has data sources. I hope I'm not confusing you lot, but I'm trying my best to make it as simple as possible, but it can get complicated, so please stick with me. If you're confused, dial back a little bit. And so these kind of match. The models are the proper implementations for the entities. Remember, these are contracts, no proper implementations yet. So the implementation happens in the data layer. So the data layer implements this. The repositories are implementations of this. The data source is an implementation of nothing. It just talks directly to the server. Now this repository that lives in the data layer will be an implementation of this, meaning it's a type of this repository. So since the use case is actually depending on this repository, a repository of this particular type, we can go ahead and pass it the implementation rather, but it still depends on this type. But because these two are the same type, because this is a subclass of this, it will work when we pass this directly to this person instead. So this is the contract that connects these two, but when we're actually using it, we don't pass the fake contract or just the contract, because the contract does not have a body. It doesn't have functionality. It's just a contract. So we pass in the actual implementation of that contract, right? So similarly, when we're defining what a repository function will return, say a register function would return a user entity, or a user, essentially a user object. Now we will go ahead and give it the type of this. We're telling it your type would be this because it's a contract. We're telling whoever's writing the implementation we want it to be of type this, but we don't know what that type would do. We don't know if it will copy with, or if it were to JSON or to XML, or from JSON or from XML, and so forth. So, but all we care about is the definition of what it has, and that is it. So someone else can go ahead and implement the entity and give it whatever functionality it's meant to have, and they do that by making a model. This is very dirty, but please stick with me. So these are also connected to the repository indirectly, because the repository functions return entities. So a register will return a user entity that lives in the entities layer, in the entities little sub layer, and so forth. The other one can return, let's say, an admin or an order, depends on what feature you're in. So let me reiterate. Presentation talks to the adapter talks to the use case talks to the repository. Now the repository goes ahead, because we've passed it the actual implementation and not just the contract type, the actual implementation will talk to the data source. Now the data source will in turn join this little queue that is going to the server. So we can essentially clean this line because the user is not directly talking to the server, but the data source is going to directly talk to the server, right? So when they do talk to the server will send a response. Forgive me again, this is getting very dirty, but let me do the eraser thing. Alright, we're done cleaning up our little mess, so let me make this a lot more vibrant. Oh, sorry, I'm still in the eraser mode. Put it back there. Yes, so the data source is directly talking to the server. It gets that information back from the server, right? We put that this way. It gets the information back, so there's information flowing back to the data source. Now the data source communicates that information again back to the repository implementation. The repository implementation returns a model, which is an implementation of the entity. The repository returns an entity. Now the repository's implementation returns an implementation of the entity. I hope I'm not confusing you lot. Lord, that sounds so stupid. But I hope I'm not confusing you lot. Right? I'm trying my best to come down to the basic level, but I hope I'm not overcomplicating stuff. But we move on. So this is how the flow works. Take your time. Don't rush it. Don't memorize the layers. Don't memorize their relationship. Take your time and do it over and over and over again. You can do little practice projects. I know it's a lot of work, but the more you do it, the better you get. The more you even see more patterns and all that, and how it actually helps you. So now this person's talking back to the returning models. Now they're not talking to models, they're returning models. So their return type will be models. They're just simply functions, right? It's just a module of functions. So they return that model, and this repository implementation, remember, is indirectly connected to this use case. So when this repository will be responding to the use case, it will be in the form of this. It will be from here. So this person thinks they're talking to this person, but we've tricked them by passing them this person, a fake wife. They think they're getting married to you, but they're actually getting married to Rachel, and Rachel's not a very good person, so we're faking that. So they're getting married to Rachel instead of Abby. So we do that little proxy thing, and we return that response to the use case. The use case sends it right back into that little pool of data, of information. Now remember that the presentation spoke to the pool first, so the pool will literally tell the presentation that something's happened, and the presentation will do what? Send it right back to the user. So let's go through the flow one more time. So presentation talks to the adapter talks to the use case, and the use case talks to the repository. The repository is going to talk back to the use case through the data layer, because we're passing the use case and implementation from the data layer. So indirectly, the data layer is actually talking to this little pool through the use case. The use case thinks they're doing that through this repository contracts, but we're actually doing it through the data layer's implementation of that contract. So these people are connected, but not directly. So I'm going to oh my days. So I erased that little connection because I want it to be indirect. So it's going to be a dotted line, not a straight plain line. It's going to be simply dotted, and it goes this way. Come on, man. Right, so it goes that way, dotted. So it's not directly communicating, but it is through a weird connection. So hopefully this makes it clear. I'm going to try my best to do a last run. If you've already understood it, move on to the next section, but if you haven't, come with me. I'm going to try to do a last run, not a full explanation, but simply a summary of some sort. For the summary, we've still got the same setup. We've got a server and we've got a user. Now, user needs to talk to the server, but there's a very thick, very thick layer of wall between them, right? So they can't properly communicate. Now we have to help them do that. So we create a solution. This is our environment. This is our solution. This solution in here needs a way to handle communication with the server, and finally communication with the user, and also communication within itself, both for our benefit, right, the developer, for our experience. So when we're searching for things and when we're trying to debug or swap out certain elements in our solution, certain parts of our solution, so that way it's a lot easier. And then we have the other benefits of it, which is better communication flow, or better yet, have a sturdier composition of different functional parts of our solution. So and that's where this architecture comes in. So for this architecture, we've got a little domain, right, and we've got a user interface that talks to the user, and finally we've got the data layer. So this is usually called presentation, domain, and this is the data layer. So we've got the interface adapter, and that's what I've called IA, interface adapter. So the interface adapter in our architecture, because I told you that we're not directly using Uncle Bob's version of the clean architecture, you adapt it to your framework. And what I found is we can totally put that, not make it a separate layer, but put it as part of the user interface, because it's essentially a major part of it. So now the user interface receives data from the user. It finally passes that data down in here. So let me put that in here. It passes it down to the interface adapter. So this actually goes both ways. So back and forth. Same happens here. It passes it into the interface adapter. The interface adapter depends on use cases that live in the domain layer. Now, these use cases are actual classes that represent single functionality. So it embodies the SRP principle, single responsibility principle, from the principles of Solid, which are very good principles in programming generally. Right, so this is what we're doing. Let me leave that in there. So single responsibility. So each function or each functionality has got its own class that embodies its responsibility. What does it do and who does it talk to? And we also use that as a front to match that connection between the domain layer and the data layer, because in there we're depending on the repository. Right, so in a use case, we depend on a repository, and whatever repository is passed to us, we want that repository, right, to call the function that relates to that responsibility, to that functionality. So we will see that in code, but just have this at the back of your mind. It's an indirect way of connecting us to the data layer. Now, this is why there's dashed lines, because it doesn't give us a direct connection. It's quite indirect, right? If you had an override of the repository type in a different layer, you could still pass that in here, which we do in testing. When we follow the principles of TDD, we can pass it a fake version or a mocked version of a repository. So that's not really coming from a data layer, but it's still going to work because it wants a repo of a certain type. So in that repo of a certain type can come from anywhere at all. So, but then in the case of a functioning application, an application that's literally in production or something, we want it to come from the data layer, because the data layer will get us live data from the server, not fake data from any tests that we've got on the side over here. That is essentially how it goes from there to there. Now, this person using the use case will get this inherited when we're in production. Essentially, we'll inherit the repository implementation that we've put in here. Now, the repository implementation over here is connected to a different thing, a different module in there, right? It could be any source. So it's connected to a source of information. It could be a local source if you're fetching from the user's cache, or local storage like shared preferences and the rest of them, right? So if it's not that, then it's going to be fetching from a remote source, meaning now it's leaving this ecosystem and it's going outside of these constraints and it's going to the server, right? So now it's escaped, can't speak, it's escaped the constraints or the boundaries of this environment. So now it's going out to the server to fetch information. The information goes both ways. So it sends data, it sends a request with data if necessary to the server, which we've created using Node.js, and the server sends a response. Now this person here catches a response, makes it a little easier to read, and then sends over that exception if it's got an exception, or the data if it's got data, back into, still in here, still within this package, sends it back to the repository implementation, which depends on any type of source, right? And then that repository implementation will further refine it into a Dart readable failure, right? So that Dart readable failure, that's not an exception, because exceptions throw. This failure won't be a throwable. It can't be thrown, so it won't crash the application, right? So we handle it and we create a finer version of a failure and finally pass that back to the domain use case, and the use case is actually going to take it back to the interface adapter. The interface adapter responds and maybe emits a state if you're using block, or if you're using provider, it will change the state, or however you're handling your state management, whatever state management solution you're using for this interface adapter, that will adapt and it will alert the UI that something's changed. The UI updates and the user can see that. So the user can see that little update or get the information they want from the updated user interface. So this is essentially the summation of all of it. So let's get right into the code.